supermarket warehouses or department stores. Think of a department store. The department store has a certain layout. Well, you can optimize your warehouse, but then if in a department store there's a batch of products and this first product has to go here and the second product has to be all the way in the back of the department store and the third product in the box has to be in the middle. You're walking throughout the entire department store just to get rid of one small box. That's not a good idea. So even though the warehouse might be at first sight less efficient, they would typically match the warehouse layout with the department store layout. So it's more efficient in the department store and less intrusive to the customers. Accuracy. I saw a very nice medical facility that ships tents, and they have a lot of different sizes, and they're all about this size, white boxes, this high, different sizes, different expiration dates. They had single locations, and it said size 14, 16, 18, 20, all in the same compartment, different expiration dates. And the picker had to kind of search all the boxes to find it. Well, it works because they had to scan, and if the box was refused and they had to go back and search again. So the accuracy was okay, but at a high price of searching. And you can imagine if you don't do the checkup, accuracy will suffer. So there's a lot of factors here, even though most articles and the next couple of slides will just discuss low travel times. So what is a good location, speaking of travel times? Well, basically, most warehouses have a starting point for the order picking tour. You pick up your empty cart or empty pallet or whatever at some location, that's where you start. Well, logically, the good locations are those that are close to that starting point, right? You start here, pick something there, you return and you're done. Much better than to go all the way to the back. Or, from an ergonomics point of view, at waist level. Because if products are stored at waist level, it's much easier to grab the products. It's much less training for your body as well. It's faster and it will keep your workers in better health. There's a couple of articles of, I think, Peterson, and I'm trying to get one published on this as well. So, inspired by, I think, I spotted this example at Georgia Tech like 10 or 15 years ago. It's still about the same, but slightly changed, I guess. So this is a warehouse, a very simple warehouse. There's just one aisle and pallet handling. This is the starting point. Any pallet that goes in or goes out starts here. So if I have to retrieve a pallet for a customer, I start at the dock, I drive maybe to location 7, take it back, drop it off for shipment to the customer. That takes me 55 seconds to do that. If I have to get the product from location 11, it takes me 65 seconds. That's the logic of this line. Now, what is the amount of products that we have to ship? That's here. So from product X, we have to take out 40 pallets every month. From product C, you have to take out 20 pallets every month. They get shipped first in, first out, so you can't mess around with sequencing of the products. Every product goes out in sequence. Now the question is, where do you put X, where do you put Y, where do you put Z to optimize your travel time? I'll give you a few seconds to figure this one out. Yeah.
Well, I guess the classic approach is to consider the throughput to storage volume volume ratio
Mm-hmm.
and assign those products to the product ratio for the closest
Right.
location.
If you do this with your students, you'll, well, at least my experience is that about half will put product Y closest to the dock, which is the one that ships most. Right? Highest selling item. Problem is, as was remarked already, that Y does ship a lot, but it also takes a lot of locations. Storage is 40 pallets, which is 8 locations. So that's 1, 2, 3, 4, 5, 6, 7, 8. So locations 1 through 8 will be filled by product Y. And the other products will be right here. But how often do you go to this one location of product Y? Well, you go there like pallet ship them. You ship 60, but you store it in 8 locations. So I'm really bad at doing math in front of the classroom. That's like a factor of 4, right? 8, 5, 13? Is that right?
You're looking at ratio 60 by 8? Or
60 by 8, yes.
7?
7.5, right? So you have to go to each location 7.5 times. Whereas this is the 13, right? You have 3 locations for X, and you go to each location 13 times. So that's a much better, more important location. You have to go here 13 times. You have to go to a Y location only 7 times a month. You have to go to a Z location 20 times a month. So even though this is your most sold item, it's actually from a warehousing point of view, considering total storage volume, your least important product, and you put it in the back. So Z goes into location 1, X goes into 2, 3, and 4, and Y goes into the other locations. And that will optimize total travel time in a warehouse. I have it calculated somewhere. I'll make sure that you can get it afterwards. You see all the numbers. But that's the basic principle. It's not just about number of picks, though I guess 80% of the scientific articles will just talk about pick frequency. There's also the volume, storage volume, which is in most articles considered constant. Every product takes the same storage volume. That may be true, but it may not be true. If it's not, you have to do some adjustments. Actually, this dates back to, I think, 1963 or so, this idea. Okay, this was an easy example, right? It was one straight line with storage assignment. Now, most warehouses have multiple aisles, and you also have to make those decisions. I will just look at one method for storage assignment. These are all the others. If you want to go into literature or books, be my guest to look them up. I will just look at ABC storage, where I divide all the products into 3 categories, A, B, and C. A being the ones that have the highest pick frequency. Well, adjusted for volume, right? We know that now. Highest pick frequency A, C, lowest pick frequency. And then you still have to decide where do you put the A's, where do you put the B's, where the C's. Well, 3 options. Dark means A's, medium is B's, and light blue are the C's. We already know A's go close to the dock, right, to the depot, because you want to be in and out as quickly as possible for the products that are demanded most frequently. But I have 3 ideas. Which one is best? Any opinions? So if you would have your own warehouse and you would have to do ABC storage, which one would you choose?
The last one.
The last one. Since a lot of your research is on full pallet handling, it's a good option. It depends. So if you do, just imagine you do one pick per route, one product. You go in, you go out. Well, then this is close volume. Maybe make more of a circle shape. But this is optimal because the blue ones are the ones that are in distance closest to the depot. So the expected distance to one location is minimized in this option. So this is good for one pick per route. Just imagine what happens if you have to go to 2, 3, 4, 5 or 25 locations before you return to the depot. Well, now, sorry, I think that's for you, right? Okay, I'm back online. Now you have to go to 20 locations. Well, just imagine going here for the first pick, then you have to go back out into the second aisle, into the third aisle. You have to change aisles a lot for larger pick lists. Whereas in this option, once you're in the aisle, an extra pick, well, it might be here. Just a little bit of extra distance. But the extra distance that you get here is much more. So pick list size is basically the driver of choosing between these systems. This one is always worst, actually. This one never works out. It's always this one or a fourth one that's not in this picture. This only works well if you have a lot of congestion. So if you put in like tons of pickers and they start bumping into each other, you want to spread out the ace as much as possible, so you spread out your workers and there's less congestion. Otherwise, this one or this one, and I can show you.
Doesn't it also depend on whether you've got one-way or two-way picking? So if you've got one-way picking, you've got a fixed route through. If you've got two-way picking...
If you have fixed routes, it might change, yeah. I'm assuming free routing.
So again, if you've got narrow aisles, you're going to get a lot more congestion with anything apart from the middle one, because that way you've got a fixed route through.
Yes, I'm not assuming fixed routes. This is the picture. I did a lot of instances, a lot of different situations. And this is the pick list size. And on the vertical axis, you'll see the percentage of the instances where the method was better than the other storage methods. And you see if